Okay, so I'll just wait to check that the live stream's working. And let some more people on the call.
Is there a tweet about it? Because or a toot we can boost?
Yes, there is. So for people on the live stream, we're just getting set up. Just give us a second. Okay, so you just asked for a tweet. Open arms. Yeah, if you go on the London Bitcoin Devs Twitter, there should be a tweet saying we're on in now or something.
Yep.
Okay. So yeah, we should be live on YouTube. Sorry for the delay. Okay, good. So yeah, this is a discussion on Assume UTXO. We're lucky to have James O'Byrne on the call. There is a reading list that I will share in a second with a bunch of links going right from like concepts, some of the podcasts James has done, a couple of the presentations James has done, and then towards the end, hopefully we'll get like pretty technical and in the weeds on some of the current or past and future PRs. So yeah, so let's just do intros while I let a few more people on the call. Yeah, James, you want to do a short intro and then we'll go through anybody else who wants to do an intro. There is the ability to raise your hand if you want to participate, or you can just interrupt. Either's fine. So we'll go to you, James, first.
Cool. Well, thanks, Michael, for putting this together and for having me. It's nice to be able to participate in meetings like this. My name is James O'Byrne. I've been working on Bitcoin Core on and off for about 6 years. Spent some time at Chaincode Labs and continue to work full-time on Bitcoin Core today. So yeah, excited to talk about Assume UTXO and answer any questions anybody has. The project's been going on for maybe 2.5 years now, which is a lot longer than I anticipated. But yeah, I'm always happy to talk about it. So thanks for the opportunity.
Awesome, thanks, James. Anybody else wants to do an intro? You can either just unmute yourself or raise your hand. Otherwise, you don't have to. Yeah, feel free. If you don't want to speak, feel free to ask questions in the chat. I'll monitor the chat and any comments on YouTube. But yeah, if no one wants to do an intro on the chat on the call. No. Okay, everyone's shy to begin with. Okay, so let's start with. Well, yeah, I'm gonna we generally start with basics, just so because some people who are more beginners will get lost later. So I'm going to pick on some like volunteers to discuss some of the basics. So like the first question is like, what is initial block download? Why do we do it? Why do we bother validating the whole blockchain from Genesis? And if I don't have any volunteers, I'm going to pick someone. So does anyone want to try answering that question? Otherwise, I'm picking someone. Okay, OpenOms, please explain why we validate the whole blockchain from Genesis. What's the point?
Right. So I think the point is to build the current UTXO set, so we can see what coins are available to be spent currently and which have been spent before, and we do it by validating all the blocks, downloading all the blocks from the Genesis block from the beginning, and going through which coins have been spent to where, and ending up with the current chain tip which will end up building the current UTXO set as well, so we can know what has been spent before and what is available now.
Okay, cool. Any additions on that? I will get the reading list up. and share the screen because there was a good explanation from Andreas. Anyone, any additions to that?
Yeah, I guess, I mean, maybe if you think of the state of Bitcoin at a very high level, if you think of the state of Bitcoin as being a ledger, you want to validate for yourself without taking anything for granted the current state of the ledger. And the way that you would do that is by basically replaying every single transaction that's ever happened to create the current state of the ledger and verifying for yourself that each transaction is valid. And so that's essentially what the initial block download is. Oh, you're muted, Michael.
Okay, welcome to a couple more people on the call. I'm just going to share my screen. So just give me a second. So the initial blockchain download. So we're replaying absolutely everything from Genesis. So like all the rule changes, all the transactions, all the blocks, and eventually we get to that current blockchain tip as now the second. So this does take a very long time to do. There's a few posts from BitMEX and Jameson Lott on just how long this takes. And although there have been improvements in recent years, it still can take hours or days, depending on your machine and your hardware. Any experience from the people on the call on how long this takes? Or has anybody done an IBD recently?
Yeah, so it's a couple of hours on a higher end hardware, like with a i7 processor and a decent amount of RAM. But on like a Raspberry Pi with 4 gigabytes of RAM and an SSD, it's about between 2 and 3 days.
And so James,
yeah, I was using Raspberry Pi, but it took me like 5 days or something with SSD, but same order of magnitude.
So that's on a Raspberry Blitz, 5 days.
Yeah, it depends a lot on the peers you end up downloading from. So, for example, if you have a full node on your local network and you add it as a peer, then it can be quite quick in that sense. So it's and also if you are using downloading through Tor, that can slow down things a bit, a lot. I mean.
Okay. So obviously it would, from a convenience perspective, like spending hours or days in this state where you can't do anything isn't ideal. So from a convenience perspective, like a better thing to do would be to try and shorten that time. And the obvious thing to do would be to just download blocks or validate blocks from a certain point in time rather than from Genesis. So I think like the first attempts at like either bringing this time down or at least providing some assurance to users that are not spending hours or days verifying the wrong blockchain was Assume valid. Is anyone on the call aware of Assume valid other than James? We have, let's go to Fabian. Fabian, can you explain your understanding of Assume valid?
Okay, first I had to stop chewing, and then I had to look if there's another Fabian on the call. So Assume valid is basically a point in the blockchain, like a certain block height and or block hash, from which point we can assume, or it is assumed sort of that this is not going to be reorged out, basically. And these are hard-coded in the Bitcoin Core code base. But this feature, like the idea, I don't really know, like this is before the time that I got active in Bitcoin Core, so I don't really know what the conversation around that was exactly, but it's not really used anymore. So there's no new assume valid points are being introduced regularly into the code base. But I'm not 100% sure like what the discussion was around that and what the latest status is around that, what people's opinion is on that.
So yeah, we'll go to James. I just highlight like what I've got on the shared screen, which is like it was introduced in 0.3.2, so very early, and the intention was more to prevent denial of service attacks during IBD rather than shortening the time of IBD. Presumably at 0.3.2, the time of IBD wasn't anywhere near as long as it is now. But I think, and James can correct me, but I think it either did at that point or later, it skipped validating signatures up until that assume valid block. Is that right, James?
Yeah, and it looks like when it was introduced, it was called checkpoints, which ended up being a pretty controversial change because basically a checkpoint dictates what the valid chain is, and that's subtly different from what assume valid today does, which is just say if you're connecting blocks on this chain and it's you're connecting a block that's beneath the block designated by the assume valid hash, then you don't have to check the signature. It's not ruling out other chains, which is what checkpoints do, which I guess was the idea, was to prevent denial of service attacks because maybe someone sends you a really long chain of headers, but that chain of headers has really low difficulty associated with it. So yeah, checkpointing is a different thing than assume valid. And so, as you said, assume valid really just skips the signature checks for each transaction below a certain block as an optimization. It doesn't rule out another longer valid chain from coming along. So, for example, if someone had been secretly mining, a much longer chain than we have on mainnet, with some unknown hash rate that's much greater than the hash rate we've been using, they could still come along and sort of reorg out the whole chain hypothetically based on use of assume valid, whereas checkpoints don't allow that. So checkpoints are a little bit controversial because they hard code validity in the source code, whereas assume valid is just kind of like, well, this is an optimization, if that makes any sense.
So yeah, sorry, continue.
Oh, I was just going to say, it's worth noting that with assume valid, obviously we're still checking a lot about the block. We're checking the structure of the block. We're checking that the transactions all hash to the Merkle root, and the Merkle roots go into the block header, and the block headers connect. So you're still really validating quite a bit about the block. You're just not doing those cryptographic signature checks that the community has done over and over and over again.
But just to be clear, the assume valid is still being used nowadays, right? It's just the checkpoints are deprecated, but assume valid is, to my understanding, still being used in the current version as well.
Yes,
okay.
So assume valid is used by default. It's the default configuration, and typically every release, the assume valid value is bumped to a recent block as of the time of code. So that typically happens every release. Oh, okay. So Calvin is saying that checkpoints are still used. They're probably just really low height and could probably be removed. Yeah, so assume valid is still very much maintained. It's the default setting, and if you want to opt out of it and do a full, signature check for the entire chain, you can do that by passing the value 0 for assume valid configuration.
Just a point on removing like the old checkpoints. Technically, that's a hard fork because
Yeah,
yeah.
yeah, exactly. Because it would broaden the consensus rules. It would allow blocks that were previously invalid to be valid. So you're right about that, Calvin.
So with the existing checkpoints, it's technically impossible to validate a chain which has different checkpoints to those checkpoints, say in core or another Bitcoin implementation.
Yeah.
It's impossible. Okay. So then, but with assume valid, what happens? Obviously these are unlikely scenarios, but let's say you were validating a chain that didn't meet an assume valid. It didn't agree or match with an assume valid. What is the user experience then? Is it just flagged to the user? Is there a log that says the assume valid in the code doesn't match the chain that you're validating? Because, or is it based on proof of work? What's the user experience if that assume valid isn't matched with your experience of validating the chain?
So it's still possible. It would basically, if we were considering a chain that was more work than the chain that we know now that violated, the hard-coded assume valid default, that would indicate a reorg of thousands and thousands of blocks. So it would probably be, catastrophic at a higher level, but I think the most that you would get as a user is maybe a log statement. I don't even know if we have a log statement for that case, but if something is on a chain that isn't assumed valid, you just do the signature validation. It's not any kind of special behavior.
So the difference in performance would then be that you can skip signature validation until the previous assume valid. No, there's only one valid hash in the binary, so it's not that you can go back to the previous valid hash. It's either all or nothing. So if there is a chain like a reorg of 1,000 blocks, a couple thousand blocks, then the user would have to validate all signatures since Genesis block, and not since the assume valid hash of the previous core release.
That sounds right. I'm not sure offhand. I'd have to check the code.
Right, because there's only a single hash in the code, right? Whereas for checkpoints, you have one like every, I don't know, 50,000 blocks, but for assume valid, it's only a single hash. So
I think
that hash is backed by like minimum chain work, right? So there's some checks to make sure that you're on the right chain.
Right. So yeah, minimum chain work is definitely another relevant setting here, and that basically prevents someone from sending a really long chain of headers that may be longer in a strict count than mainnet, but is lower work.
So this is relevant in a Assume UTXO context, obviously, because because the concept is that you're going to validate only a fraction of the chain and then potentially do transactions. So like pay or receive, having only done a fraction of the initial blockchain download. And then the rest of it from Genesis would be happening in the background, but you're already functional, you're already up and running, you're already potentially doing transactions and paying and receiving.
Yeah, that's the sketch of Assume UTXO. With Assume Valid, you're still downloading all the blocks, so you have all the data on hand. Assume UTXO just allows you to basically take a serialized snapshot of the UTXO set, deserialize that, load that in from a certain height, and then in the same way that with Assume Valid, we expect that by the time the code is actually distributed, there are going to be hundreds, if not thousands, of blocks on top of the Assume Valid value. The same would go for Assume UTXO. So we would expect that the initial block download that you have to do is sort of truncated, but it's not completely eliminated, so that you're still, downloading a few thousand blocks probably on top of that snapshot.
Okay. So I mean,
and then as you said, in the background, we then start a full initial block download.
Right. So okay, so yeah, let's just go over the concept then of Assume UTXO. So I've got the Optech topics page up. So we're bootstrapping new full nodes. We're reducing this initial blockchain download time, at least, well, by only doing a fraction of it before we're able to send and receive transactions, before we're up and running. Like you can, during IBD, you can still like play around with your node, right? You can still make RPC calls and like do CLI commands, etc. But like you can't do anything with the wallet until you've fully completed IBD. Is that right?
Yeah, that's right.
Okay. So yeah, so the concept of Assume UTXO. So one thing this says in Optech is embedded in the code of the node would be a hash of the set of all spendable Bitcoin. So is that correct? Are there alternatives to embedding it in the code of core? I think you've talked before, James, about like getting this like UTXO snapshot out of band and then using like an RPC command to start the process. And then it wouldn't necessarily be in the code of core or the implementation you're using. Is that right?
Yeah, so the value that's important to hard code is just the hash that we expect. If you take the UTXO set, which is just the collection of unspent coins, and then you order them somehow, and then you hash them up, you get a single value that's a lot like what the sort of value you might get at the root of a Merkle tree or something. And so hard coding that is important. It's more important to hard code that and not allow it to be specified through the command line, say, in the same way that assume valid is, because if you can allow an attacker to give you a crafted value of that hash and then give you a bad snapshot, then they can really mislead you about the current state of the UTXO set before you've finished back validating. So so we decided, in the early stages of designing this proposal that value should really just be hard coded in the source code and shouldn't be user specifiable unless you're recompiling the source code, in which case, anybody can tell you to make any change and potentially, cause loss of funds that way. But yeah, so to your question, once you have that value, the UTXO hash hard coded, you have to actually obtain the file of the UTXO set itself, which is serialized out, and that's going to be on the order of 4 megabytes or so, depending on how big the UTXO set is, of course. And
gigabytes, right?
Yeah, gigabytes. I'm sorry, did I say something else? Yeah, 4 gigabytes. Oh, oops. Yeah, definitely not 4 megabytes. So in the early days of the proposal, there was a kind of like phase 1 and phase 2. And phase 1 just added an RPC command that allowed you to activate a UTXO snapshot that you had just obtained somehow, whether that's through HTTP or torrent or Tor or whatever. And the idea there is that it really doesn't matter how you obtain it, because if you're doing a hash based on the content of the file anyway, the channel that you get it through doesn't have to be secure. So it's like, when you download a copy of Bitcoin Core, you don't necessarily care about the HTTPS part if you're checking, that the binary hash validates against what you expected. So the same idea here. And then phase 2 is going to be building in some kind of distribution mechanism to the peer-to-peer network. In my opinion, phase 2 is looking less and less likely, just because it would be a lot of work to do. It requires the use of something called erasure coding to basically ensure that we can split up UTXO snapshots, and so no one node is burdened with storing too much. So it'd be a really, really big job, and in my opinion, it just it doesn't matter how you get the snapshot, and there are lots of good protocols already for doing decentralized distribution of this kind of stuff, you know, via torrent, say. So so now I think it's less likely that, you know, there will be a bundled way of getting the snapshot within core, although that's certainly not out of the question.
So yeah, so these are the two phases that you've discussed in other forums, James, like podcasts, presentations. You said phase one was allowing snapshot use via RPC with no distribution. So this would be getting the snapshot from potentially anywhere, right? A friend, a torrent, whatever. And then phase two, which you say is unlikely now, is building that distribution into the peer-to-peer layer. Which, yeah, I was thinking that sounds very difficult, because then you have questions over like how many nodes are actually supplying it and whether you can actually get a hold of it, and core has to decide, well, core and other implementations have to decide how recent a snapshot they need to provide.
Right.
Which gets hairy, right?
Absolutely.
But then isn't the problem that you're making it very, oh, sorry.
No, go for it.
Yeah, isn't the problem that you're making it very difficult for kind of novice users to use Assume UTXO if they have to go and kind of find those binaries themselves, in addition to making sure they get the correct version of Bitcoin Core? Like if it's not all bundled, you know, they're probably not going to do it, or they're going to rely on third parties like, you know, Umbrella or Raspberry Blitz to kind of build it all together for them. But then if you kind of push even more towards that model, then you also assume that those third-party providers, and of course, I do trust OpenHomes and everyone else to do it properly, but then they might also tamper with buying.
Yeah, I think you're totally right that there is a convenience trade-off there, and I mean, it's unfortunate that it's not easier for us to just kind of make this a seamless experience. My hope, I guess, is that eventually, once the RPC commands are merged, we can work on a GUI change that would just allow someone to basically, you know, drag and drop the serialized UTXO set into the GUI or something, and then maybe also link to a torrent for the snapshot, you know, from bitcoincore.org, where you get the binary, and it could, you know, could say, hey, if you want to expedite the IBD, then, you know, just do this. But you're totally right that it does complicate things for the end user. I just think, in my experience, I thought that these changes were fairly simple for phase one, and I thought that they would be integrated, you know, within a year and a half or so. And it's you know, now 2.5 years later, and we're not even, you know, we're maybe 60-70% done with phase one. So I'm just very pessimistic about the pace of doing what I think is a much more complicated change in terms of the distribution stuff.
I think, like, also the types of users that really want this. I mean, the question is like, who really wants to get started within an hour or so of plugging the node in? And I think like there's a big overlap of the people that really want that, and the people that get like a Raspberry Blitz or an Umbrella or whatever is going to come next, that is like really plug and play. So like this feature matches really well with, I think, that user base. And then like making more available for other people that are more on the self-sovereign side, I would say, or like, let's say that they do more a little bit like by themselves. I think that would be great for them as well, making it easier for them as well. But I think like this is where I see the biggest leverage, and where the adoption will be like very, very soon when it's available, because the Raspberry Blitz people are asking for it all the time, and like the what's it called, BTC Pay server basically built like their own type of feature that was kind of a hacky Assume UTXO that was not completely trustless, and so this is yeah, I think that there's a very good overlap of people that are going to use this, and that are like from this crowd.
Oh yeah, if I can add, there is like a use case for example, the Spectre wallet, if you know it. So some people who would want to use a self-validating kind of wallet connected to Bitcoin Core, and obviously get started as soon as possible. They have a similar solution to what BTC Pay Server uses, but even more trusted. I must say the website is prunednode.today, where you can basically download a signed version of a pruned snapshot of a node of Stepan Stingerev, basically, and get started with that with a pruned node. So you don't even need to have the storage available for the whole blockchain, and you obviously don't verify it then. And there is another alternative which like LND uses already on mobile by default, by the Breeze wallet, for example, which is the Neutrino BIP 158, I think, where and also the Wasabi wallet on desktop does use this, that you only download the block hashes as needed, and not more than that. So it's more like it's more like a light wallet function rather than a fully validating one.
Yeah, that's a good point, OpenNoms. And in the early days of this proposal, we were actually debating whether it would be easier to just kind of integrate a more SPV-like or light client-like behavior into Bitcoin Core instead of a proposal like this. But it turned out that for a variety of reasons, this seemed preferable. Number one, it just seemed like actually less of an implementation burden, because to build in SPV behavior to the node in a first-class way would really be a big change. And the second was that I think the validation model here is quite a bit better actually than SPV, because with a full view of the UTXO set, you can do first-class validation for recent blocks at the tip, and have better assurance of that.
Yeah, there is no risk of having information withheld from you, like with the BIP 185 or with Neutrino.
Yeah,
because that's the worry there, that you are getting blocks which not containing the transaction you're after.
Exactly. Yep.
So we're kind of on the security topic now. So like, this is the security model, and we won't spend too much time on this, but we should cover it. Because presumably like this is like slowed progress on it. Do you think, James, that like there's different perspectives? There's like a perspective that you perhaps you shouldn't make any transactions, like send or receive transactions, until you've done a full initial block download. I'm assuming some people think that. Then you've got like people in the middle that are kind of like, oh, it's okay if the snapshot is really, really deep, like, I don't know, years deep. And then others will say months deep, or some would say weeks. Like, is that the concerns over security slowing progress on this, or have slowed progress until this point?
I think in the beginning there were some misconceptions about security, and really there was only one developer who I think had consistent misconceptions about security, and that was Luke Dash Jr. I think he's now in favor of the proposal. But I think there are a few important aspects here. Number one, as someone mentioned earlier, there are a variety of approaches now with basically, PGP signed data directories that people are passing around that I think are very subpar. And I think everybody who's doing that has good intentions, but it's the kind of thing where now if one person's PGP key gets compromised, or, one hosting provider gets compromised, then, you have the possibility of some really bad behavior. Number two, initial block download is a process that's linear with the growth of the chain. And if the growth of the chain is going to continue indefinitely, that's sort of an infinite process. So at some point, this needs to be truncated, to something that's not infinite, which Assume UTXO does. So I think that just needs to happen at some point, and I think this is the most conservative implementation of that. So in terms of the security model, and specifically, the only way that this kind of deviates from, and the third thing is that this is an opt-in feature, right? So unlike assume valid, which is a default setting, you have to proactively use this. And so at least at this point, given this implementation, users aren't, sort of nudged into doing assume UTXO in the same way that they are with assume valid. So I think that's an important consideration. Now maybe one day this will be some kind of default, but again, I think there's a lot more that will go into that before that's the case. So it's important to think about how what kind of risks this introduces over assume valid, because one of the main differences between assume valid and assume UTXO is that in assume valid, you still have the block, you still have the structure of the block, and you're validating, that the Merkle root hashes check out. Whereas with assume UTXO, all you have are the results of that computation. In other words, the UTXO set. And so the way that you really would attack assume UTXO is to both give someone a malicious UTXO set hash that they're going to put in their source code, and then to give them a maliciously constructed UTXO snapshot. Right now, if you just give them a maliciously constructed UTXO snapshot, its contents will be hashed, and the hash won't validate against the hard-coded hashes in the source code. And the thinking there was that if someone can modify your source code arbitrarily, if someone can insert a bad assume UTXO hash into your source code, well, there are all kinds of easier ways to cause loss of funds or steal your Bitcoin. And so if you assume someone can get to your source code and recompile your binary, then you're already cooked anyway. So it doesn't really matter. And so I think aside from that, there really aren't any practical differences in the security model between assume valid and assume UTXO. But I'm curious if anybody else has thinking on that.
I mean, it really depends. In a model where core was putting a snapshot into the code base that was whatever, thousands of blocks deep, right? Or months, years worth of blocks deep. Yes, as you say, the only concern there is someone having control over the binary in its entirety, in which case they can do anything. But I'm just thinking about this scenario where it's like, well, people are just passing around snapshots between friends, and perhaps someone uploads a snapshot that's way too recent. How is core or a code base going to stop people from using snapshots that are way too recent, that it really doesn't make sense to use them with, let's say, I don't know, 6 blocks ago or 3 blocks ago? How do you stop them from doing that?
So what happens if someone, say generates a snapshot that's 3 blocks old? What would happen is they'd give that snapshot to someone else, and then if you were using an unmodified version of Bitcoin Core, you would attempt to load that snapshot, and we would hash the contents of the snapshot, and then we wouldn't be able to find an entry in the assume UTXO data structure in the source code to validate against that, and so we would reject it as invalid. So only snapshots that are specifically, you can think about it as like a whitelist of snapshots that are allowed per the code.
Okay.
So that isn't a concern anyway. Go for it.
Yeah. There's no concern there.
I just would like to mention that, especially with transacting with a unsynced node, I mean, there's a big difference between like sending and receiving, right? Because if you can send and the network, accepts it, and especially if the receiver receives it, then there is no problem. You don't need to verify that anymore. But it's the question is when you're receiving something and you want to say that, okay, now I have confirmation, and then that would obviously need the new blocks fed to you as well, which is a much more complicated question. And
yeah, that's a great point. There is an asymmetry there.
Yes, and you would obviously wouldn't be able to verify without reaching the chain tip, so it's fully synchronizing, but you might be able to construct a transaction without doing that and then broadcast it wherever.
Okay, so this is sounding less controversial than I thought it was initially. Like, yeah.
Is there concerns where the snapshot is being taken and say a lightning channel is open and then it's subsequently closed, but you've given that snapshot to someone, they think the channel's still open so they could use that, or does lightning itself, would that prevent that money being sent?
I think that's sort of equivalent to the simple payment example, where someone gives you a snapshot and then you load in the snapshot, and until you've gotten to the network tip, the most recent block that everyone's seen, I think you can't make assertions about what's spent and what's unspent. So I think they're analogous.
I mean, is it even worth, I'm actually wavering on this now, but I came into this thinking you would definitely want the user to complete that initial blockchain download from Genesis, right? So as you say, this is conservatively designed in that you do actually complete the full IBD. It's just you do the from Genesis part after you're up and running. So then this argument of whether you should actually do that IBD from Genesis and what's the point of that seems like a question.
It is a question. And I agree that the value of doing the background IBD is debatable. And from my perspective as the person proposing this and doing the implementation, I wanted to make it as appealing and as conservative as I could. So I didn't strip that out. But there were certainly other engineers who thought that it wasn't necessary, and that if you were willing to accept the Assume UTXO security model for a few days or a few weeks, then you might as well, like in Assume Valid, we don't go and then in the background validate all the signatures after we're done syncing. So, the analog for Assume UTXO wouldn't be to do a background validation, but I figured that I'd rather people default into doing the initial block download at some point, having the block data on hand, being able to serve it to their peers if necessary, than not. But I think you raise a good question that's frankly still could be debated, and at some point might be changed.
I know there'll definitely be people who oppose that. Go for openness.
Now, my question is that with Assume UTXO, would you be able to start with a pruned node and not needing to download the full chain then?
I think Assume UTXO is compatible with pruning. It's just that basically you still have to retain enough data to be able to arrive at the UTXO set that you started the snapshot from. But it's very, I think it basically, for most intents and purposes, doesn't change pruning.
Right. So okay. Because obviously the big benefit of having a validated chain, or like having a full chain, which is, in this case, either validated or we are discussing if it needs to be validated, but why it's necessary to have if you want to be able to use an already used wallet, which some transaction history, then you should have the blocks which are containing those transactions at hand, so you can rescan and be able to reproduce the history of a used wallet. Because a pruned node is all fine until you don't need to rescan, right? Because then you would need to start from the beginning most of the time, unless you didn't prune long enough.
Yeah, exactly. And then even with that, one interesting line of thinking is to use the compact block filters and to just index those compact block filters. And then if you need to rescan, use the filters, decide which blocks you're interested in, and then go out and retrieve those from the network as necessary. But that's kind of an unrelated question.
Yes, that is this implementation of a similar idea called this Btc Rpc Proxy, if you know that. I mean, obviously this is outside Bitcoin Core, but it's kind of a service which simulates a full chain to the software calling the Bitcoin RPC interface, and it sits behind Bitcoin Core and the Bitcoin RPC basically. So what it does is since you still have a prune node, but there is a request getting to a block which is not on the chain anymore because it's pruned. It requests it like with the block filters and serves it to the requester software. So to that software it looks like it is an unpruned node, but in reality it is not, right? So
interesting.
It's an interesting, yeah. It's I'll link the software here. I think it's some like, for example, there is this full node company called Embassy, who are just running with an SD card by default, and they use the prune chain, and they also develop and use this Btc Rpc Proxy, which is then allows them to not need 300 gigabytes of storage, or like now 500 gigabytes of storage, rather just an SD card with the OS and the pruned node. But I mean, yeah, so this is basically something in between the block filters and a pruned node,
right?
Or a full node trade-offs. Yeah.
I'm guessing the strongest argument for still doing IBD from Genesis is that what you said, James, which is like, in principle, ideally, we want everyone to be able to fetch and validate the whole chain. And so if we relax that and become less conservative and, I don't know, make it slightly easier to not, well, I don't know, don't do that by default, etc., like release that conservatism, then perhaps like those blocks and transactions from the first few years of Bitcoin are just impossible to retrieve, right?
Right. And someone early in the proposal made the argument, well, in theory, everybody's sort of incentivized just to run a prune node because, why would you keep the extra storage around? I don't think they're quite comparable, because running a prune node doesn't make the IBD go faster, and pretty much everybody wants IBD to go faster. So if you're running Assume UTXO and the default was not to do IBD, I think I think if it was easy enough, almost everybody wants to do Assume UTXO because it just gives you an operable node much more quickly. And in that case, then you would then have the default of not having the blocks. And so I think in practice, it may be the case that, many more people don't have the full chain history on disk then. So I think you're right.
Yeah, maybe that's. I mean, I'm just thinking of things. There would be disagreement, I think, on relaxing that conservative default. I'm sure some people would oppose that, and perhaps there is a reason to do that. Okay, is there anything else on security? Otherwise, we'll move on. Any final thoughts or questions on the security model of Assume UTXO?
Yeah, maybe for mine.
Yeah. Go for it.
James,
you seem to be cutting out, whoever's speaking.
Sorry, my headphones keep on. Can you hear me now?
Yep. Go for it.
James, you mentioned if you already trust the developers and the core binaries to be kind of secure. Trusting the Assume UTXO hash also will introduce extra vulnerabilities, but isn't that kind of a dangerous path, because we know that different parts of the code base have different levels of scrutiny? Like consensus code gets reviewed much more often or much more in depth than maybe some test PR, and the implications that a kind of malicious Assume UTXO hash has is pretty big. Whereas this is some magic number that can get updated every core release, so maybe in 5 years' time, people won't kind of be too surprised if they see a new hash, and maybe you won't get reviewed as much. And the impacts this can have are huge, right? Because this could kind of break the whole, if it is that happens, this would have huge implications on the reliability and trust of the ecosystem. Whereas if the assume valid hash is wrong, it's no big deal. Like people might take it longer to do IBD, but no money can be stolen. There's no perceived inflation and so on. So it's like a scale of trust in developers, right? And you don't want to just assume that everything's correct all the time and kind of just go with it.
Yeah, so this is a really, really good question. And it kind of gets to the heart of the design with Assume UTXO that I feel really optimistic about, because in exactly the way that you're saying, there are certain parts of the code base that are scrutinized more heavily than others. And in my experience, working on some of the code that handles the UTXO set, it can be very, very, very difficult to reason about, even for people who are well-versed in C++, even for people who know the core code base. And so what I love about the Assume UTXO design is that it's very easy for even someone who's semi-technical to verify that an Assume UTXO hash is correct or not correct. As long as they have a full node, they can run a script and check that value. Whereas if we try and do optimizations that are slightly more sophisticated or opaque or technically complicated, there are very few people capable of actually scrutinizing those changes. It's very hard to read a lot of the coins code, and not many people these days just kind of casually browse the repo with C++ knowledge sufficient to do that. So I really like the idea of shifting the validation, or kind of crystallizing validation into this one value that, yeah, you're absolutely right, is sort of toxic waste and has to be scrutinized, but is very readily scrutinized by a wider variety of people than, like, say, the Ccoins cache code is.
And potentially could even be like automated tests could also check that if you have like independent nodes, just running, keeping a full state as well. That could be kind of independently checked to make sure that the hash is always correct. As part
Definitely,
of
yeah, absolutely. You could automatically parse the chain params.cpp file, extract out the Assume UTXO values, and then validate that against your own node pretty trivially. So that's a great idea.
Okay, cool. Any final thoughts on security? Otherwise, we'll move on to the next topic. I mean, I was thinking like there would be like a warning in the GUI if you say made a payment or received a payment without having completed IBD. I was thinking like there would be information to the user that, yeah, you haven't completed IBD, therefore there's a slightly higher risk. But I'm thinking that's not even necessary, right? I mean, the risk is not zero, that there could be some crazy reorg back there, but it's basically zero to many decimal places.
I agree. And then, I mean, I don't know what the user's action would be subsequently, I think that it's such a vanishingly low probability that there would be some kind of an attack there. And then again, if you assume that the user got a malicious binary that had a bad Assume UTXO hash in it, then they would obviously strip out that warning too.
Yeah, it seems like the only thing you can do is crash, because the binary is not self-consistent. It's like, hey, this binary has detected a state where the binary itself is assured that it would never happen. So I don't know, crash or something.
Right.
Okay, so if there's nothing else on security, let's move on. So the next topic I have up is how this, and it's good Taj is here and Calvin, is how this interacts with other projects. So at least from where I'm sitting, like this lays some foundations for doing more interesting stuff with IBD to reduce IBD time. So like this is with Assume UTXO, this is the first step to not having a linear IBD from genesis to tip, right? So this is like the first heavy lifting and like refactoring of the core code base to allow that to happen. And so one potential next step is Taj's and Calvin's project, which is UTXO, where you could perhaps, and I don't know the viability of this, have like two or multiple fractions of the chain being validated in parallel. So rather than just having the snapshot to the tip, and then when that's done, the genesis to the snapshot, you could perhaps have genesis to the snapshot being verified at the same time as snapshot to tip. I think that makes sense. So yeah, let's hear some. So we can go to James first about thoughts on whether this does actually lay foundations to UTXO, and then we'll go to Taj and Calvin or anybody else who has more thoughts on that. We'll go to you first, James.
Yeah, I'm definitely eager to hear Calvin and Taj talk about UTXO, but I'm really happy that it seems like a lot of the prerequisite refactoring for Assume UTXO has already paid some dividends in terms of a project from Carl Dong called the Bitcoin Kernel, which is basically trying to, in a really rigorous way, separate out the consensus critical data structures and runtime from Bitcoin Core, so that we can, sort of have other implementations safely wrap the consensus stuff, and then, do different implementations of the mempool or peer-to-peer network. But just as some general background, first of all, refactoring in Bitcoin Core is not often kindly looked upon. And so having the Assume UTXO project as justification allowed me to do some fairly fundamental refactoring that would have been hard to justify otherwise. But the way that things previously worked was that in the code base, there was basically a global chain state object that managed, a single view of the UTXO set, a single view of the blocks and the headers. And what we did in lieu of that is introduce an object called the chain state manager, which basically abstracts a bunch of operations on the chain and allows us, in the particular case of Assume UTXO, to have a background chain state and a foreground or active chain state. And so that's what we do right now. But in principle, the abstraction of the chain state manager allows us to do pretty much anything. And we could have, any number of particular chain states running around doing things, being validated, and use the chain state manager to abstract that. So it's a nice, it's a nice feature of the code now to be able to do that.
Yeah, I mean,
Hey,
Calvin, do you want to talk at all about your, because I think Calvin has written a bunch of code to do exactly that with, running multiple threads at once or even multiple machines at once doing it.
Yeah, so James talked about you could have like a background IBD and like a little bit of IBD that from the assumed UTXO set, but with UTXO, what you could do is well, first of all, what the UTXO project is it represents the UTXO set in a bunch of different Merkle trees. And so it allows you to represent the UTXO set in a very few hashes, like just the root of each Merkle trees. So this reduces the size of sort of how you could represent things. So with Assume UTXO, where you have to like hash the entire UTXO set, it's UTXO, it's Merkle treeified. So you just take these roots, and that's what you would validate against. And so like that is essentially your UTXO sets. So you just take those. So basically what you could do is you could represent the UTXO set at a height in less than a kilobyte. And that allows a lot of flexibility. So whereas before you had to download these 4 gigabytes, now you don't really have to. So it's possible to just fit everything into a binary. So that sort of almost solves the problem of distributing like these 4 gigabytes. Introduces a bit of other problems, but yeah. So what the projects that I've been working on is where you have just a bunch of different threads going, and you sync each thread is syncing a different part of the chain. So like, let's say you start up 3 threads, and one would be syncing like 0 to 1,000, other would be syncing 1,001 to 2,000, and the third to like 2,001 to 3,000. And once all those are finished, you would check against the provided the UTXO set representation. So if you start from Genesis and end at block 1,000, well, that's where you were provided the accumulator roots at. So you would compare against it, and if they match up, great, you just saved a bunch of time because you already started verifying from 1,000 to 2,000. So you just do this a lot, and it allows for more efficient use of your CPU cores. And you could go on further to just say like, hey, we don't even need to do this on a single machine. You could split the IBD into multiple machines. So a really fun thing you could do is you could have a phone and your laptop do IBD validation at the same time. And it doesn't even have to be continuously. So like if you have, say, like a Raspberry Pi going in the background, you could be like, hey, I'm sleeping, so I don't need my laptop. I'm going to use my laptop to help my Raspberry Pi node sync up. So those are some fun things you could do. Or if you're like, hey, I trust my family. So, hey, could you bring your laptop? We'll just do the IVD. And there's a lot of fun things you could do like that.
Yeah, and I guess, well, Calvin, so we have software that does this, and the sort of testing software, and it does seem to give a big speed up. Where if you say, okay, even on one machine, if you're like, well, let me have like 8 threads that are all independently doing IBD from different points in the blockchain, you just get a lot better usage of your CPU, because like you've got so many different things going on. And they're small enough that you can sort of throw them around and keep them in CPU cache and stuff. So you do get a bit of a speed up there.
You're looking for this one. Posted it on the chat.
So from a high level perspective, this seems like a big change rather than like a refactoring type reorganization change that Assume UTXO seems to be.
Yeah,
like, I think James. Okay, sorry, go for it. If I'm wrong,
there's different P2P messages.
I've heard UTXO. So it can't. It's got a different commitment structure, right? So it can't use rolling hashes.
No.
Yeah, I'm just please just elucidate or elaborate.
Yeah, so it has a lot of.
How much of this is building on Assume UTXO?
Yeah, I mean, they're conceptually there's some similarities, and it would be cool. Maybe we should. It would be really cool if there was a way to switch between them, or somehow to say like, well, if you have your Assume UTXO sort of giant UTXO commitment, you could turn that into a UTXO style commitment, or vice versa. It's not super obvious how you do that, because in UTXO it matters the order that things were inserted and deleted because of how the accumulator works. So it's not like you can just, given the UTXO set, generate the commitment state of UTXO, right? So you can't, we don't have it, like maybe someday we can make something like that. That would be really useful, but we don't have any software right now to say, okay, take a current node that's synced up and it's got its chain state folder with the level DB of like the 80 million or whatever UTXOs that exist, and take all that data, which is what the UTXO sort of accumulator represents, but take all that data and turn it into a UTXO accumulator. We can't right now because there is sort of this, the order things were added and deleted changes the accumulator, unfortunately. So it's not just, okay, what's in it? So yeah, UTXO does need its own like weird messages, and you have to send proofs, right? It's not just, whereas in Assume UTXO, nobody's gonna know you're using this, right? Nobody you're connected to sees any difference. Maybe if they're really trying, they can be like, he asked for block 700,000, and then a few hours later, he asked for block, 5. So like that's weird. But even that, you'd have to be connected to the same serving nodes and stuff, and it'd be hard to tell. Whereas something like UTXO, it's totally different messages, right? It's very clear, and if no one's there to serve you these things, you're not going to be able to use it. So it's a bigger change in that sense.
Yeah, and I think really the strongest relationship between the two is that the Assume UTXO work from a core implementation standpoint kind of paved the way to make it easier to do UTXO in a sense. Like some of the abstractions that it introduced are going to make it a lot easier to sort of airlift in the UTXO operations without, doing, because it really, it took probably about a year to get in just the really foundational refactoring necessary to move away from a single chain state and a single, UTXO set.
Yeah, and that's super useful. And we haven't, the stuff we've been working on is also like some of the things looking like dealing with multiple chain states, but also dealing with not having a database is kind of even like, wait, what? Like there is no database, and a lot of the software definitely assumes that you've got level DB thing there, and that's what you're using when you're validating blocks and stuff. And so a lot of the software is like, okay, well, there's ways to sort of pretend that it's there, or make a sort of disposable chain state every time you validate a block, or things like that. But that's some of the refactoring we've been looking at, which is probably going even further than the changes in Assume UTXO. But yeah, definitely, using that and then, changing even more.
Yeah, so for anybody who isn't familiar with UTXO, and Calvin Tadge, correct me if I'm wrong here, but UTXO kind of inverts the validation process in the sense that instead of checking some, all-encompassing UTXO set, whether a coin is spendable, you basically just attach a proof along with the transaction that shows that given a Merkle root for the entire UTXO set at some height, that the coin exists in that tree and is spendable.
Yeah, and one thing I do want to clarify: a lot of people think it's sort of a UTXO commitment scheme. In the software we're using, and I think even just theoretically, there's no commitment. So the miners or the blocks never tell you what that UTXO set is. Similar to today, if you're downloading a block, there's no indication what the UTXO set is. You generate it yourself, and hopefully everyone's UTXO set is the same because they started from nothing and sort of built the same thing based on the blocks. But in UTXO as well, no one gives you that. You build it yourself, and so it's very much a direct replacement for the database. Right, no one's going to give it to you, but you build it yourself, and hopefully everyone's is the same. It's a bit different in that if everyone's is not the same, it breaks. Whereas today you may have a slightly different. Hopefully we don't. That's a bug, but you may have a slightly different UTXO set than someone else. Maybe because, and one bug like we saw when we were working on this is like stuff like op return or like is unspendable, things that you immediately can see and like, well, I'm not going to even put that in the UTXO set because you're never going to spend that, right? You can totally run a Bitcoin core node where you put all the op returns in the UTXO database. It'll work, right? It's a waste of space because they're never going to get spent, but you could do that. It'll still work. With something like UTXO, that becomes like a consensus rule, which is kind of scary because if everyone doesn't have the same set, the proofs are no longer compatible. And so like if someone says, well, I put in op returns or I put in these kinds of things, they're going to be incompatible. So that's a little scary. But yeah, that's another sort of issue there. But I did want to clarify that because a lot of people, there has been so much talk over the years about like commitments. You're like, hey, let's commitment to the UTXO set in like some kind of message the miner makes, and this does not do that. That may be something that you could later do with the same technology, but that's a whole other can of worms. So none of these are doing that, I think, right now.
Yeah, and then it was worth noting as well that at some point there was talk about incorporating a UTXO set hash into the block header so that instead of having to specifically hard code Assume UTXO hashes into the code base, we could just use the block headers. But like Tad is saying, that's a much bigger question.
Yeah. And you don't need to, like, and that's the thing, like a lot of people think it is this, and it's like, well, I don't know that it actually gives you that much in either case, right? If even Assume UTXO, it's like, well, you're going to want to validate the last couple weeks or months anyway, and you can hard code that far back in the binary. So like, does it really help that much to have miners committing to these things? Like, I don't know, right?
Right. Because then, I mean, that's a fundamental shift of trust towards the miners as well.
Right. And it doesn't seem like, even if you were willing to do that and say, okay, let's make this a commitment, there's a lot of downsides. One, I think the biggest that I've talked to people about is UTXO, at least for UTXO, it keeps changing. We have cool ideas and we're like, oh, whoa, now it's twice as fast as it was last month or something. So you definitely don't want to commit to some kind of soft fork, because what if you find a way better idea in a year and now you've got this like soft fork thing stuck in that no one wants to use anymore. And also it doesn't seem to get you that much, right? Like it doesn't, for the risk and the change in trust, it seems like you can sort of do a lot of really cool things without that. So probably not, I haven't really even looked into it that much, because it's like, well, it doesn't seem like it helped us that much. So let's not even go there. And I think, I don't know, James, is the same sort of idea with Assume UTXO, right? Like it doesn't seem like there's any need to involve miners.
Absolutely, yeah, absolutely. I mean, given it's taken 2.5 years just to do the implementation, I didn't want to undertake anything even getting close to a soft fork. So
yeah. So I mean, that's what's cool about it, though. It's like these improvements that aren't even forks at all. And so if you want to use it, cool. And if you don't, and that's one of the things we talk about a lot with UTXO. It's a big enough change that like it's going to be hard to get into Bitcoin Core, and rightly so. Like Bitcoin Core is quite conservative with like changing all this stuff, and it's a pretty big change. So some of the stuff, it's like, well, let's try sort of testnet versions that aren't core and play around with that first, and maybe it's the kind of thing where people use it for a year or two even without it being merged into core, and then it's long enough and sort of well tested enough that people are like, okay, we can move it in now.
And I was going to say that hopefully with Bitcoin Kernel, it might even be practical or advisable to do UTXO as a kind of separate project. But at the same time, I think you guys are going to be modifying so much of what is considered consensus critical that that the benefits of having a shared library like Bitcoin Kernel probably aren't as much as if you just want to do your own mempool or do a different peer-to-peer relay.
Yeah, well, the messages are different, but it would be like, I do think, and I've talked to other people who are interested in sort of Bitcoin Kernel, consensus, that kind of stuff, that getting rid of the database code as consensus code is something people are very interested in. Like I know, talking to Fanquake, like Fanquake got rid of OpenSSL in Bitcoin Core, I don't know, a year or two ago, and he was like, if we could get rid of LevelDB, that would be amazing, right? If you can get rid of, because LevelDB is pretty big and does affect consensus, it would be great if it didn't, or if it was sort of walled off or isolated a bit more, because LevelDB seems fine and everyone's sort of using it and it's okay, but like, yeah, the transition from what was it, Berkeley BD to LevelDB was sort of this big unintentional hard fork, and that's a scary thing to do if you want to change database stuff, but you may want to in the future. So sort of walling that off would be another project that we want.
Yeah.
and this is part of it, right? You've sort of already, you sort of need to wall it off a bit to do things like Assume UTXO as well.
Definitely.
Okay, we could definitely have a whole session on UTXO, but we should probably move
I don't wanna take
just final question. I'm just trying to understand like how they could potentially play together. Like, could you perhaps do like a normal IBD from snapshot to tip, and then use UTXO from Genesis to snapshot, or I don't know how are they going to play together? Would you use
that?
both?
You could do, you couldn't do the opposite. You couldn't say, I'm going to do normal IBD from snapshot to tip, and then without doing the, Genesis to snapshot, do UTXO, because unfortunately right now, UTXO does need to sort of build itself up from scratch. If you want to then prove things. But yeah, you could potentially do something like that. That's sort of a weird case, because you're like, I want to start really fast, but then I want to be able to provide like all possible services to everyone, which could be a use case.
Just to note, feature-wise, I think they're fairly different. It's just that conceptually and in terms of code, a lot of stuff that needs to happen are the same. So that's where they sort of
it would really be cool, and that's something I don't know we should look at to get like and that's no Cal. I did talk about that a little bit a few weeks ago, like with this different accumulator design. Maybe there are ways to switch from a complete UTXO set and into the accumulator itself. So then you could have something like right now, Assume UTXO does have this sort of hash that it hard codes in and says, okay, here's the UTXO set. Go download it and make sure it matches this hash. If you could also make that something that would accept UTXO proofs, then that's really cool, right? Then it sort of works for both, and maybe nodes that support one could provide UTXO set data to the other and stuff. I don't know how to do that yet, but it's something I was like, I have some vague ideas that I'm like, oh yeah, I need to work on that. So that'd be cool if it were possible. It might not be, but yeah.
Okay, very cool. So there's a few other like proposals or mini projects that I thought we'd briefly cover. So I think Fabian's still here. Like the impact of the rolling UTXO set hash on Assume UTXO. Have you used this as part of Assume UTXO? Like, at least in my understanding, there was an intersection between these two projects. Is that correct?
I mean, I guess I can answer for James. Like, there's not really an intersection. Like, of course, the hashes that are used now could use the mu hash instead, but it right now uses the quote unquote legacy hash of the UTXO set. So and like what James was already working on Assume UTXO when I just got started with this stuff. So the whole UTXO set project was based on the old style of hash, and it was very unclear if and when the rolling hash, the mu hash, would get in, and so there was really no reason to change that. And I mean, now it's in. There could be like potentially in the future, instead of the serialized hash, the mu hash could be used, and that would give some like some upside if you run the index, the concept index, then it's much easier to get like hashes of UTXO sets that are in the past. And James has a script to do it with a node where you can do it as well, but basically I guess the node is not really operational while you're running the script, and it's a bit hacky. So yeah, this could potentially make it a lot nicer, but then of course you would need to make changes in the sense that these like saved hashes in the code base then would need to be mu hashes, and of course you could have both in there. But yeah, that's still a bit off, I think, because yeah, the question is then like mu hash first needs to be considered 100% safe. And I think like we still need to watch it a bit more and get a bit more experience with it and give it a bit more time until that makes sense.
Yeah, definitely. And as Fabian mentioned, the process right now for checking the Assume UTXO hash on your own node is pretty hacky, because basically what you have to do is call and validate block on the block after the snapshot block, so that you roll your chain back to the snapshot point, and then you calculate the hash. All the while, obviously, your node is not at network tip, and so not operable, and then you have to reconsider block and rewind back to tip, and that does take probably 15 minutes at least.
Okay, so as it says here, it's conceivable that Assume UTXO could use the rolling UTXO set hash, but it doesn't currently. That's right, yeah?
Yep, yeah, I think Assume UTXO is really kind of agnostic in terms of the particular commitment, as long as you hard code it. And as Fabian said, I mean, you could imagine that if we decide MuHash has, the security properties that we're comfortable with, then you could have a side-by-side listing or something to facilitate migration, or you could just move to MuHash.
Okay, cool. Any additions on that, Fabian? Let's move to the next one. So that's rolling UTXO set hash. So we've done UTXO. There were a couple more that were interesting. I don't know if James or anybody else wants to comment on these. There was the UTXO database backup that has been open for a number of years from Vlad. Does anyone want to talk about that?
I don't know if I've ever even really looked at this in depth.
Okay, it's fine. And then the other one was the UHS. I don't know what UHS stands for, but that was a post from Corey Fields back in 2018 on full node security. It's what, sorry?
Unspent hash set, I think.
Unspent hash set. Okay, very good. Thank you. Without maintaining a full UTXO set. Again, any comments on this? I thought it was related.
I know a bit about that. It's sort of a I mean, definitely talking to Corey about that stuff was one of the things that led to UTXO. And it's sort of, hey, instead of, let's keep level DB, let's keep the UTXO set, just instead of storing like, the out point and the pub key script and the amount and all that stuff, let's just take the hash of all that. And then you do need to send these sort of, proofs, I guess, the pre-images when you're spending a transaction, but they're very small because most of the data you can get from the transaction itself. Like you just can't get the amount, I guess, because you don't know exactly how many Satoshis, but like the TXID and index itself, you'll see right there in the input of the transaction. And the surprise sort of fun thing is most of the time you don't need the PK script because you can figure it out yourself, because for like you see the pub key, like for less regular old like pay to pub key hash, you see the pub key posted in the input and then the signature, and you're like, well, I'll just hash that pub key and see if it matches, and it should if it works. So you only have to send like 12 bytes or something for each UTXO you're spending. And so we use the same, we use this code and this technique in UTXO as well. But it's, so this is a much simpler thing though, because you still have the UTXO set in your database. It's just hashes instead of the pre-image data. And it's not that much smaller, but yeah, you can see it's like, like cuts in half-ish.
Okay, very cool. Okay, any more comments on that? Otherwise, we've spent longer than I expected on the conceptual stuff. Let's talk about the implementation in core then, to finish. So like the evolution of this, James, you had the prototype that was just to, I don't know, check it works or convince people that this was worth, convince yourself and convince others that this is worth pursuing, right? You said that this wasn't mergeable, this is just, prototype. Any interesting things that came out of this other than just like initial feedback?
Yeah, so that started out as a rough prototype. I think it was a single commit when I opened it. And it's slowly evolved into something resembling mergeable. So at the moment, I think it needs a rebase, but beyond that, from my perspective, it's code that could be considered for merge. And what I've been doing is trying to carve off little bits of it and open separate PRs so that, you know, each change can get kind of the appropriate level of scrutiny. And maybe people can goad me into actually writing unit tests and things like that. So this PR does kind of represent the current state of everything needed to do Assume UTXO, and I'm regularly testing it.
Okay, I misunderstood then. I thought like you'd spun off all the other PRs, and that was the implementation of it that you thought was going to get merged, and this was just like the first attempt. But have I misunderstood that?
Yeah, it initially was just the first attempt, and then bit by bit, I've been keeping it up to date with the changes that I do make, and then all the merged PRs so far have been commits that I've carved off of this one.
Okay, I misunderstood that then. Okay, and then
one of the incidental sad things about that PR is that it's got so many comments and so much discussion now that it's almost impossible to navigate based on GitHub's UI. So yeah, I don't know what's to be done about that, but yeah, it's
a lot of people complain about the GitHub UI and comments.
Yeah,
it's a massive headache.
Can't live with it, can't live without it, kind of thing.
Yeah. So James, you also talked earlier about Carl's work. So he deglobalized chain state manager, which I'm assuming allowed progress on Assume UTXO. So you needed various you needed to get rid of various globals, right, to be able to do Assume UTXO at all.
Yeah, so there were a few globals. One Pcoins tip was a pointer into the UTXO set itself, or the Ccoins view cache, which is the in-memory kind of cache entry point into the UTXO set. And then another was chain state active, which or I think it was C chain or something. I can't remember the name of it, but it was a global representing the chain state object, which is basically like the block index and a few different things there. And so I had to, I'm sorry, the block index was a separate global itself. But anyway, so I just had to take a few globals and then package them up into this chain state manager, which itself became a global, but then Carl came along and made the good change of removing that global, instead favoring passing the chain man as an argument to the various places that it's needed. And so that allows us to just do better testing, not rely on global state as much. And I guess to eventually, consolidate all the consensus critical stuff into a shared library, which is what he's working on now.
Okay, cool. Because that was a big project in itself, wasn't it?
Yeah.
But I suppose that you could still have a global chain state manager that manages two chain states.
Yeah, exactly. That's the whole point of the chain state manager versus a particular chain state object.
Yeah. Okay. And then there's the PRs. That was the issue.
Yeah, that was the issue. Yeah, the issue in the original prototype PR got a little bit muddled in terms of there was some conceptual talk happening in both places.
Yeah. So the project has all the PRs. We don't have to go through all of them one by one. Like quite a few of them are refactors, right? Certainly the early ones were refactors. Chain state manager was an early one that we were just discussing. That's been deglobalized by Carl. Any particular ones that have been merged that are worth discussing or worth pulling out at this point, James? You still there? I think we may have lost James. Can people hear me?
I could hear you.
but I
Okay,
think James is
you can hear
present.
me. Okay, well, that's going to be a problem if we're going through the PRs. We'll give a few minutes, give a couple of minutes to see if James comes back. But yeah, otherwise, I was just going to wrap up on the PRs that have been merged and the PRs still to be reviewed. Well, let's give James 2-3 minutes to see if he comes back, and then those 2-3 minutes, let's go back to UTXO. Like what's the current status of the project, Calvin or Taj? I saw there was a implementation in Go, right, using the BTCD implementation.
Yeah, we mostly work in Go. Yeah. I know that Nicholas and Calvin as well is sort of making some C++ code, but I think we're sort of working in Go more initially, just to sort of try things out and then port it over to C++. I think someone's was working on a Rust version as well.
That was me.
Oh yeah.
Sorry about that, lost connection.
Okay, cool. Back to
yeah. So yeah, if anyone wants to join just UTXO on, oh wait, it's not Freenode anymore. Whatever the thing that came after Freenode was, is
Libera.
Yeah,
Libra
the one that everything.
Sorry.
Yeah.
Yeah. So there is a IRC channel for UTXO. Is it like hash UTXO?
Yep, just like that. Yep.
Okay, cool. Okay, now James is back. Sorry, James, we were just talking about UTXO again while we waited for you to come back. So in terms of like the PRs that have been merged, are there any particular ones that are worth discussing, that are worth pulling up of the ones that have been merged? And then we'll discuss what still needs to be merged.
I think the UTXO snapshot activation thing could be worth a look. I think the chain state manager introduction is kind of interesting, but I think to talk through them here is probably kind of laborious. So I would just say if you're interested, they hopefully should be fairly clearly titled, so you can go and read through the changes for any that you're particularly interested in.
Okay. So no particular context for reviewing current PRs. So let's
I think a lot of the stuff that got merged is pretty self-contained, and the upshot of what you need to know is that now there's this chain state manager object, and there's an active chain state that's the chain state that's being consulted for the legacy operation of the system. So if you want to check if a coin is spendable or do validation, you consult the active chain state, but there may or may not be this background chain state doing stuff in the background. And so that's kind of the current state of where we are. And right now, for example, the one of the PRs that's open, the have load block index account for snapshot use, is really just adapting different parts of the system, in this case, part of the initialization, to account for the possible presence of, a background chain state that we have to treat a little bit differently than the active chain state.
Okay. And in terms of like the review and testing, so it looks like you've only got one PR left to get merged, right? And then will that be phase one completed? There's a couple of
I wish that were the case.
Okay.
So this and there's actually another PR that's open that I guess so Fanquake's been very kindly kind of maintaining this project because I don't have the GitHub permissions to add stuff to projects. So there's another change in parallel that's being considered in addition to those 3 or 4 PRs up there. And basically, what I don't want to do is open all the PRs I want to get merged at once, because I think that'll just overwhelm people. So I kind of gradually, as merges happen, open up new PRs. If you want to see all the commits that have yet to go in for the completion of this phase 1, you can just go to the Assume UTXO PR that kind of has all the commits that are required for that to happen. That parent PR that I tend to link to in the PR descriptions.
5, 6, 6.
Yeah. So that's a listing of all the commits that are left to go in.
And what's an easy way to test it? I saw Shaw's had found a bug or two and done some good reviews just by playing around with it. Like, what could people do to be useful? Is it functional in a way that you can, say, use the RPC and try to do IBD from the snapshot?
It should be.
Or is this limited functionality need to be tested? Yeah.
It should be pretty usable. So right now there's a hard-coded hash at, I think, height 685,000 maybe. And Shores and I have at various points been hosting the UTXO snapshot for that over torrent. So you can clone this branch, build it, and then play around with doing an IBD using that snapshot. We could probably create a more recent one, but I just haven't kind of thought to do that recently. And then there's I've bundled a little script in Contrib that allows you to do like a little mock usage on mainnet, where it will spin up a new data directory. It'll do a little, it'll sync maybe 50,000 blocks, which happens very quickly. It'll generate a snapshot, and then it'll tell you what to recompile your code with to allow you to accept that snapshot, so that you can actually kind of demonstrate to yourself that the change works, which I use basically as a kind of system or functional test to make sure that the main branch still works.
Okay. So it's functional, yet there's still a lot of commits and a lot of code still to merge.
Absolutely, yeah.
Okay. So they're just refactors,
really,
or like,
sorry?
How is it working now, despite there being a lot more code still to get merged?
It's working only if you clone.
Oh, if you use your branch, right? Okay.
Yes. Yeah.
Okay.
Yeah.
I understand. Yeah. Gotcha. Okay. Okay. So, any edge cases or tests that need to be written? We've already. Yeah. I was trying to think of edge cases, but like the edge cases I was thinking of would be like a snapshot that was really recent, and then there was a reorg or something. So that's not possible. I'm trying to think.
I think somebody needs to test. It'd be great to have a test where you're like doing pruning and building all the indexes to make sure that code still works, because I don't think that I've tested all that stuff very rigorously. There's no reason it shouldn't work, but it definitely needs to be tested. Yeah, with pruning and indexing both enabled.
And why might this be a problem?
There are some like accounting complexities, because the way that the indexers work is that they consume these events on something called the validation interface queue, and I had to introduce a new kind of event that is basically, so there's like a block connected event, and I have to distinguish, for the purpose of index building, between a block connection on an active chain state versus a background chain state. And the index now is being built out of order instead of in order, because obviously if you're connecting blocks from the tip, and then afterwards connecting blocks, early on, that's kind of a change in assumptions that the indexers were making. And then pruning, there's some new pruning logic that basically ensures that when we prune the active chain state, we don't erase blocks needed by the background chain state. So there's just, a few changes in there, and yeah, it'd be good if someone, tested that stuff, which I will at some point, hopefully in a formalized, functional test in the test suite. But right now there is a functional test, but it just does pretty basic UTXO snapshot operations, and does test a little sync between two separate nodes using snapshots. But I haven't gotten around to writing tests for the indexers and pruning.
I have a pull request open where I changed the way, like, the indexes or the pruning is blocked when indexes are running. And so in there, I extend the tests for pruning and indexes together quite a lot. And so then I think it would be easy to add that on. So I think, yeah, that should be easy to add after, like when that gets merged.
Oh man, that's right. Yeah, I think I act that, right, Fabian?
I hope so. Yeah, but there are some comments that I need to address. Yeah.
Oh man, yeah, that was. I think I reviewed that maybe a few months ago. That would be a really good change to get in. So if anybody's looking for things to do, yeah, reviewing that PR is a good one.
What's the PR number, Fabian? Do you know?
Now, second, it's 21,726.
Yeah, okay. I can do that another time. Okay, so can people still hear me? I feel as if I've dropped off the call.
Yep.
Okay, cool. Okay, so any other final comments, questions? Otherwise, we'll wrap up. Anybody have final comments or questions? If not, okay, we'll wrap up. So thank you very much, James. That was brilliant. Thank you for everyone who attended. It's great to hear about some other projects, UTXO and Raspberry Blitz, etc. Yeah, the YouTube video will be up, and I'll do a transcript of it as well. But yeah, thanks everyone for coming.
Awesome. Thank you for having me, and really great to hear from everybody. Some really insightful stuff.
Cool.
See you.
Good night from London. Thanks. Bye-bye.
See ya.
Thank you.
Yeah. Thank you all.